Alright, in this video we're going to look at the Isosceles Triangle Theorem and kind of go through a couple examples and see how it relates to sides and angles. So first things first, the theorem itself involves isosceles triangles. We know that isosceles triangles are triangles that have at least two sides congruent, which means it could be three sides congruent as well, which is of course a regular triangle. In this green triangle right here, we have these things right here, which we'll call legs. Alright, the leg is congruent to the leg. We know that from the tick mark. Alright, the theorem says if that's true, this is a conditional statement. So the if statement, the hypothesis is if these sides are congruent to each other, then the conclusion tells us that the base angles are congruent as well. The base angles are the angles across from the congruent sides. And it also applies, the converse also applies as well. If you have angles given first, then we know that the legs across are congruent. Alright, example 1. So here we have the task to find the value of x. And the only thing we're given are these two angle arches, these red arches. Well, we need to know that if the base angles are congruent, then the sides that are across from them are congruent as well. So x plus 15 is equal to 7. So x is -8. Really simple. To check your work, of course, you want to put it back in to the formula. So -8 plus 15 should equal 7, and it does. So we're correct. Number 2. Alright, angle 2 is given to be x plus 60. So writing here, that is x plus 60 degrees. Alright, and the only other thing we're given is the fact that we have tick marks. Right, so which tells us that, let me erase this, which tells us that if the legs are congruent, then the angles that are across from them are congruent. So we go and we mark those angles right now. The two red angles are the same. 84 is given as well. That's this top angle up here. I mean, I say top, but you know, since this triangle is kind of down on its side, it's just kind of like the third angle out, or the odd angle out. A lot of times I'll call that like the apex angle, because it's kind of like at the top of the triangle. It's not a base angle. In any event, we first need to figure out that, well, I guess there are two different ways to do this problem. Alright, let's go through method A, and then I'll show you method B. Alright, so method A is to make a copy. We know that angle 2 and this angle are the same, so we can just make a copy of them. So now we just use this triangle sum theorem that tells us that x plus 60 plus x plus 60 plus 84 equals a whole triangle, which is 180. Combine like terms, x and x is 2x, 60 and 60 is 120, plus 84 is 204. Subtract 204 and we get -24. X is -12. So that's method A. X is 12. Alright, method B would be to use a little bit of a different strategy here and first figure out what the measure of angle 2 actually is in terms of a degree. So to do that, again, we have to understand that angle 2 is congruent to this angle. Their measures are the same. Well, I know that a whole triangle adds up to 180. So what I'm going to do is right away I'm going to get rid of 84. I'm going to subtract it from the equation here. So that's going to be 96. Alright? And then I'm using the fact that these angles together, they sum to 96, angle 2 and this angle down here. Since they're the same, they're going to be, it's simply going to be 96 divided by 2. right, which is 48. So strategy B is to figure out the actual measure of angle 2, which is 48 degrees. All right, we can check that quickly. 48 and 48 is 96, and 84 is 180. All right, once you have that, the other piece of given, or the only really piece of given information at the top here that's written is that measure of angle 2 equals x plus 60. Well, they're the same, right? If measure of angle 2 equals 48 and the measure of angle 2 also equals x plus 60, transitive property tells us that these are the same. So set them equal to each other. X plus 60 equals 48. Subtract 60 from both sides and you get negative 12. Same answer. Number 3. The Isosceles Triangle Theorem tells us that if we have sides congruent, then their base angles are congruent as well. So the measure of angle 2 is equal to 65 degrees. That's really simple. But it's also equal to 6x minus 1. So again, the transitive property tells us that if the measure of angle 2 equals this, and the measure of angle 2 equals this, then they're both congruent. So you set them equal to each other and solve. We'll add 1, and we'll divide. X is 11. Now, by the way, as kind of like a bonus exercise here, to figure out the measure of the apex angle, all you would do is take 65, this is also 65, together that's 130, subtract that from 180, and you get the apex is 50 degrees. Number 4, last one. First thing I'm going to do is I'm going to look at my tick marks here, and I'm going to go across and mark that these angles are the same. Alright, next I'm looking at this exterior angle, 136. So I remember exterior angles, you know, we can kind of like transfer inside using supplementary angles. So this is 44, right? Remember these form a linear pair total, so it's 180. So 180 minus 136 is 44. Alright. Again, 2 ways to do this problem. I will show you both ways. Method A is to make a copy. Method B is to figure the measure out first. Alright, in method A, I'm going to literally put, I'll use a green here, I'll put this angle as 6x plus 14, this one 6x plus 14. They're the same, so I simply set up my isosceles, or excuse me, my triangle sum theorem. I'm using the interior angle, not the exterior. And I'm combining like terms. 6 and 6x is 12x, 14 and 14 is 28, plus 44. 28 and 44 is 72, equals 180. Subtract 72 from both sides, I get 108. And let's see, 12 times, it's got to be 9, right? Yeah, x is 9. Alright, you can check that, right? You check it back in here. 6 times 9 plus 14, that's 54 plus 14, that's 68. So 68 plus 68 plus 44, that should equal 180. So that's 136, yeah, that works. Alright, method B. Method B would be to figure out the actual measure of angle 2 first. Alright, we've already brought our 44 inside. So again, this is just like one of the previous example 2 actually. So we're going to figure out the remainder. These two angles add up to 136. You remember our exterior angle theorem confirms that, right? These two far away angles add up to be the exterior angle. Great. Okay. So if they sum to 136, and they're the same, just divide 136 in half and you get 68 degrees. So I know the measure of angle 2 is 68 degrees. Well, it just so happens that it's also equal to 6x plus 14. Transitive property tells us these are the same. 6x plus 14 equals 68. So 6x is equal to 54, x is 9. Same thing. So 4 quick examples there on isosceles triangles. Hope it helped.